I think we can request our Kaustubh has come. Kaustubh can do his presentation. Kaustubh, you introduce yourself again. Kaustubh is basically a Gnanaprabodhini, student. And incidentally, he was a neighbor of Dilip Kulkarni. In fact, Dilip's mother considers him as a first grandchild. So they are so close. Now, of course, he has shifted his house from Dilip's place. And incidentally, he is also working on hydrogen, which is green hydrogen. So he is the right person. Over to Kaustubh. You are going to do the PowerPoint presentation or just a talk? The choice is yours.
We can hear you, Kaustubh ji. You start your presentation.
Yeah. Okay. I'll start now. So basically, I'm working in the field of bioenergy, biomass to energy, and as a part of that, in my earlier tenure with KPIT, I was working on hydrogen generation from biomass. Now since I've moved on from there, I am considering all other aspects of biofuels as well, which includes biomethane, bio-CNG, biomethanol, ethanol, and the upcoming fuel about which people are talking about is dimethyl ether or DME. So that is all something that I'm working. But however, as I had discussion with Vasudevji, I'm going to speak about sustainable hydrogen and how it is impacting the lives now. So I just present my slides over here.
Yeah, it's visible, Kaustubh.
Yeah, perfect. Let's make it a full screen. So I hope the full screen is visible now.
Yeah, it is visible.
Yeah, okay. So this was a presentation that I made along with my colleague around 6-7 months back. This is about overall hydrogen and how we are considering it as an important fuel for the future. So is it really a promising option, and what are the ways, and overall, as people are talking about sustainable hydrogen and green hydrogen, what is actually hydrogen and its background as an energy source? So just some basics about hydrogen. If you see, hydrogen is a kind of a element that is present all over the universe. About 73% of universe is made up of hydrogen only, and 25% is helium, and rest all other elements that we talk about are around 2% of entire mass that is available in the universe. Despite of this fact, hydrogen is not available in free form. If you look at it, you will have hydrogen in compounded form in hydrocarbons, in various petrochemicals, other compounds, but it's not available readily in free form to be utilized as a fuel or the energy source. So if you see the free hydrogen on the earth, the percentage of that is less than 0.005% in the air. And under the crust also there is some hydrogen available, but how the quantum or the quantity of the hydrogen is yet to be explored and to be analyzed how much quantity is available in the crust itself. So it's the first element that we know since Big Bang. If you see, it's the first element that was formed out of energy, and then through fusion multiple elements started forming from hydrogen. So later on, as you say, hydrogen is then helium, lithium, beryllium, and now if you see in the periodic table, we have 118 elements discovered so far, and hydrogen is the first or primitive element of them. Now, I don't go into too much of science over here, but hydrogen has a unique properties. Uh, the column in which hydrogen is placed right now, it's column of metals. So all the metals that we know, like lithium, sodium, potassium, all those are in this particular column. Hydrogen is placed on top of them because the structure wise or chemical property wise, it has certain characteristics which match with these elements. However, sometimes hydrogen also acts like a non-metal where it receives electron to form compounds. So the second last column, if you see fluorine, chlorine, bromine, so all these things where the reaction happens, these elements receive electron to form compounds. So hydrogen also acts sometimes like these to form chemical compounds with metals. So sodium hydride, lithium hydride, potassium hydride, magnesium hydride.
If you are moving your slide, we are not able to see the slide that you are. It still shows
Oh,
first slide.
is that so? Is that so? Just a minute. Some problem. Just a minute.
Yeah, now the slides.
Now you
are
can see it, right?
Yeah, now we can see it.
What I'll do, I just keep it this way only so that you can see this.
In Google Meet, sometimes when you make full screen, no, the slides don't move.
Yeah. I think this should be. You can see the slides on the bigger way. Is this all right?
Yes.
Yeah.
And now I think you can read the content as well, right?
Yeah.
So as I was saying, hydrogen is available abundantly in the universe, but it is not available in the free form. So it's around 73% of mass is made up of hydrogen. But however, if you talk about its availability, especially on Earth, it's less than 0.5% in the free form. There are also speculations that hydrogen is available under the crust of Earth, like natural gas itself. But the quantum of that hydrogen has to be explored. The hydrogen is because it's formed as a first element, it's a primitive element, and later on through fusion reactions, multiple other elements were formed. And on the periodic table also, hydrogen is the first element on the top left corner. The column that hydrogen is the metal column, and this is because hydrogen has certain properties which match with metals. However, hydrogen also reacts like a non-metal or halide, just like fluorine, chlorine, bromine. All these elements are placed in the second last column. But when it forms like sodium hydride, lithium hydride kind of elements. These are all ionic compounds, but hydrogen also reacts with carbon like a non-metal where it forms covalent bonds. So if you look at hydrogen, it's a very interesting kind of element. It combines with different kinds of other elements to form various kinds of compounds, be it organic or inorganic. In simple forms, for the majority of the presence of hydrogen, it's like one single proton at the nucleus, one electron at the to balance it out as a atom. But there are other forms of hydrogen as well, where there are one proton and one neutron at the nucleus, or one proton and two neutron, and depending upon this, it's a plutonium, deuterium, or tritium as a kind of isotopes that are hydrogen that we have. Whenever there is deuterium or tritium available, we call it as a kind of heavy hydrogen or heavy water that is formed using these particular hydrogens. And this heavy water particularly has its use in the nuclear reactors for power generation and other stuff. In free form, hydrogen is available as a molecule where two hydrogen atoms combine to form a single molecule, which is called as H2. When we spoke about this earlier also, like it's some kind of material also, sometimes it acts as a non-metal also, sometimes it also acts as a kind of metabolite where it has some other different chemical properties. So being a versatile element, it is formed in the hydrocarbons for where it's used in petroleum products or polymers, which are typically made out of crude oil. Then it is also utilized or found in acids or hydrides, in biomaterials like biofuels, food, then other biolated elements. So it can be utilized for various kinds of applications, and like a material or input ingredient, and also as an energy source where you use hydrogen to generate energy out of it. So based on that, demand of pure hydrogen and demand for hydrogen mixed with other gases can be determined. So for pure hydrogen, it is catered through refined hydrogen through ammonia as a hydrogen carrier. For transportation, also hydrogen is stored in separately as a pure form or in the metal hydride storages. And in chemical form like methanol, then for direct reduction of ions, it is also utilized where the hydrogen is available in the mixture of syngas or in the kind of compound which where on reaction it gets dissociated from that particular molecule and is utilized as a free form of hydrogen. So this is also very interesting kind of graph where you can see the storage density and calorific value of that particular element or the product. So if you see the batteries like zinc or lithium-ion battery, they are placed very closer to the origin where 00 point is there, because their energy density is also low and their actual gravimetric energy is also low. But if you look at the other aspects, say for example, you go for natural gas. Natural gas has pretty high energy density in terms of gravimetric. So per kg, calorific value of natural gas is much more higher. However, if it is compressed at 250 bar, even at that level, the energy value of natural gas on per liter or per meter cube volume is pretty low compared to other things. Hydrogen, on the other hand, has very high calorific value in terms of per kg level, but since it is a very lighter element, the volumetric energy density of hydrogen is extremely low. Because if you see on this particular line, the hydrogen as a gas is near about zero. When hydrogen is compressed to 700 bar, it is somewhere around 8 to 10 megajoule per liter. And when it is liquefied and formed as a liquid hydrogen, it is somewhere around 10. But again, to convert into liquid hydrogen, the energy input that is required is tremendous. So that's why it doesn't become economically feasible to go for liquid hydrogen. So it's a trend that is showing about global hydrogen production. If you look at it, the hydrogen formed from refinery, from ammonia, and total production rate, and it is expected that the growth rate will go on in the next few years, considering hydrogen's demand as a fuel and as an energy source. So for the last 5-6 years, the hydrogen has become a buzzword and entire world has started moving towards hydrogen. So there are now 37 plus countries who have launched their hydrogen mission or hydrogen program around the world. They have their own plans for investments and have a roadmap in place to how to utilize hydrogen, how to have its network for generation, storage, and handling of the hydrogen. The norms, the regulations, all have been started being in place now for various countries. The leading countries in this are US, Japan, some European countries, of course, and now also India has also started, being part of these particular leading countries, along with the other countries who are also trying to adapt the hydrogen for their, energy requirements. This is not only related to hydrogen as a chemical and energy source, but as an automotive fuel as well, and that has been taken note by various automotive related companies. And there is one hydrogen council that was formed in 2017 which has the slide shows around 81 members, but the member number has gone up to 200 now, and there is more than 1.5 billion dollar investment that has gone into this to develop various fuel cell vehicles, various other technologies to utilize hydrogen as an energy source, for particularly for mobility or transportation applications. The investors are also, interested in this particular game since it is becoming a kind of hot topic and buzzword. And majority of the global investment funds are also interested in making investments, and they have also poured in around more than a few trillions of dollars into this over the past few years. So when we consider hydrogen as an energy source, there are three aspects to it. Hydrogen being used as a liquid propellant for rockets already, where the liquid hydrogen and liquid oxidizer has been utilized to produce energy when the spacecraft or rockets are being sent to the space. Apart from that, we also know the fuel cell technology where hydrogen chemically reacts with oxygen to form water and electricity. Uh, so based on this particular thing, people are right now exploring various other aspects like not to utilize fuel cell in trucks, buses, in aeroplanes, or also in the ships for transporting or commuting in the seas. Uh, Other aspect to this is now recently people are also thinking of hydrogen engines, which is IC engines, internal combustion engines, wherein you can actually modify or develop engine by making some minor design changes, and you can use engine itself to burn hydrogen and to produce energy out of it. The only point over here is that the engine will have slightly inferior efficiency than fuel cell. For fuel cell, you get somewhere around 50 to 60% of overall efficiency, whereas engine can give you at steady state somewhere around 40% of energy efficiency. However, the cost of engine production is considered to be lower than fuel cells because of various aspects where the fuel cells are little complex to make. It requires some precious elements for its construction and also some uh, high tech or refined electronics for its operation. On the other hand, engines are kind of mature technology and are pretty simple to make and has lower cost compared to the fuel cell. So as I told you, the fuel cell was kind of a thing where people were exploring for generation of hydrogen-based energy and to utilize that fuel cell in various applications. So you can see over here that the various cars that have been produced by various companies which run on hydrogen. So that is Toyota Mirai, then Hyundai Nexo is there, then Honda Clarity is also there, which are the vehicles which have been under development for many years. The first version of Toyota Mirai and Clarity came around 2013, 2014, and now the sixth or seventh version is on the road with refined efficiencies and all. So Toyota Mirai now, in one full tank, which is somewhere around 5 kgs of hydrogen stored, can run more than 500 to 600 kilometers in one full charge. So if you compare for the mileage is somewhere around 100 and 120 kilometers per kg of hydrogen. And it's not only about the passenger vehicles. There is Hyperion XP, which is a sports vehicle, which give you high speed performance as well as some high mileage also. That is also being developed. Of course, the cost for these vehicles are tremendously high, but these are comparable to some luxury brands like Mercedes or BMW vehicles. But still, people are working on bring the cost down to make it kind of viable for the common people also. Apart from that, fuel cell truck have been developed by Hyundai. There is fuel cell train that has been developed, which is running in Japan, in France, and even in India also there is one project going on for this. Hydrogen-based aeroplanes are also being worked out. There are some flights that are planned and demonstrated around the world, mainly in Europe. There are also hydrogen-based ships. So recently, one ship that was developed in Europe made a world tour that was also at Kerala for a couple of days for demonstration, and it completed its entire world tour by utilizing hydrogen as a fuel itself. In India, also we are working on such kind of projects, Especially KPIT has worked on this, where I was the part of this particular group. I was working on hydrogen generation, and there were some other people who were working on hydrogen vehicle development. So in that we developed our own fuel cell along with NCL, National Chemical Laboratory, CHI laboratory based in Pune. And utilizing that fuel cell, we developed a passenger car. We also developed a fuel cell bus, which was 100% indigenously developed fuel cell bus. And we also worked along with Cochin Shipyard to develop a catamaran vessel for water applications. So the ship photograph that you are seeing over here is a ship that was developed by KPIT and Cochin Shipyard. And that ship was launched recently by Prime Minister Modi in Kerala. And now there are plans of that such vessels should be used in the Ganga and other rivers for the intra-river kind of transportation. Fuel cell, apart from the transportation, as I said, because they are producing electricity, can be utilized for stationary power applications also. So wherein you don't want to pollute the environment and want to have silent kind of operations, there such kind of fuel cell installations can be made, which will give you steady state high power efficiency and with silent operation. So based on various energy sources, the hydrogen is called as a secondary energy source or as an energy carrier, because you are converting energy from one form to another form. So for example, if you produce hydrogen, which is called as a green hydrogen, if it is produced from solar or wind waste energy, then in that case, the solar energy is tracked, it is converted into hydrogen, and then that hydrogen is utilized for end-use application. So this kind of, you are converting one energy form into some storage application in the form of hydrogen. That's why it is called as energy carrier in most of the cases. So typical supply chain, if you look at it, you generate solar electricity using solar panels. Then that energy is utilized for converting water or splitting water into hydrogen and oxygen. That hydrogen is stored and then utilized for transportation purposes. The handling also includes supply of the hydrogen for the dispensing stations, where you use that hydrogen for your own personal vehicles. And from that, the hydrogen can be utilized for the transportation applications also. And maybe just the way people are talking about utilizing electric vehicles for utilizing them as an energy source or a battery source for running the power or supplying the power at households. Same way, hydrogen vehicles can also be your power generator or portable generators for power generation for your houses as well. There are various aspects or the sources through which you can generate hydrogen. Predominantly, it's natural gas-based hydrogen. Around 95% of hydrogen is generated around the world by using natural gas, where you go for cracking or reformation process, where you react a natural gas with water to produce carbon monoxide and hydrogen, which further on reaction gives you CO2 plus hydrogen. This hydrogen is then purified and utilized as a pure hydrogen. Mainly refineries around the world utilize this particular process for generation of hydrogen. Ethanol is also considered a good hydrogen source, where you utilize for onboard utilization, where you put in ethanol at one end, it gets cracked in the process, filtered out the pure hydrogen, and that filtered hydrogen is utilized for your end-use applications. Similarly, the coal or biomass can also be utilized for generation of hydrogen, either by gasification or by thermal cracking process. Ultimately, you get conversion of biomass or carbon plus hydrogen into CO2 plus pure hydrogen as a process. Broadly for all these aspects, where the carbon and hydrogen are important elements in all these sources. The other aspect is electrolysis, where you take water and water is split into hydrogen and oxygen by using electrical sources. The typical electrical sources could be your power, thermal power or wind power, hydropower or solar power. Based on the power that is utilized, your hydrogen is called as green or non-green. These electrolyzers are of different kinds based on their minor chemical structures or the performance reactions. These are membrane-based electrolyzers, alkaline electrolyzers where the typical electrolyte is kind of alkaline in nature, or the solid oxide electrolyzers which at high temperature dissociate hydrogen from water molecule. Then similar processes also utilized, where you don't use electricity but you use thermal input for splitting up of hydrogen from water molecule. You can do this by having high solar concentrators, where you concentrate the heat at one particular point and where the hydrogen gets dissociated from the molecules. We also use some process like photocatalytic biological systems where the microorganisms which use sunlight to split water into oxygen and hydrogen. So the microbes, if they are present in one particular reactor, those microbes will actually do the work for splitting up hydrogen and oxygen from the water molecule. Then there are also biological processes where microbes dissociate hydrogen from biomass. So they take some biological feedstock as an input. Then they disintegrate that particular feedstock into hydrogen and carbon or some low organic compounds, and you get free hydrogen as a byproduct from that. So depending upon the pathways that we choose, the colors have been associated to the hydrogen. Like gray, blue, green are the main typical classification in which hydrogen is classified. So gray is something where you use fossil fuels, and CO2 is generated as a byproduct of that particular process. So main source is natural gas over there. Blue hydrogen is something where the process is same, but you make sure that you capture CO2, which is produced in the process, and that's why the process is called as blue, or the hydrogen produced from that particular process is called as blue hydrogen. In green hydrogen, the process does not generate CO2 at all. So that is a hydrogen which is called as green hydrogen. Then apart from that, there are certain other processes, like if you use coal instead of natural gas and through gasification, that is black. If you are going to use nuclear energy for water electrolysis, then the hydrogen is called as pink. If you are going to use methane just like in your grey hydrogen generation, but the process is different, which is pyrolysis, in which you just disintegrate methane molecule into carbon powder and hydrogen, then that is turquoise hydrogen. And using particularly solar energy for generation of hydrogen is called as yellow. So depending upon your pathway, your color is associated with that particular hydrogen. So these colors can be extended as we think of different pathways. So as we were thinking when we were working on the hydrogen generation, like for example, you generate methane in biological process, which is kind of entirely carbon neutral process, and from that methane, if you are going to generate hydrogen by methane pyrolysis, so will you call it as a kind of turquoise hydrogen or super turquoise hydrogen? Or if you are going to produce hydrogen by using methane steam methane reformation itself, and you are also going to capture the CO2 that is produced in the process, but this methane is generated by biogas or microbial process by using biomass, which is again a renewable source, then will this hydrogen be called as a super green? You never know. So there are other aspects that people are exploring. We also worked on some of the pathways. I'll speak about that on the later part. So I'll just skip this. This is about hydrogen storage and utilization at the end of the use. I'll just skip this part. So this slide typically shows your value chain, like various sources are being shown, which are kind of material sources and other energy sources. So from material you go for steam methane reformation, from energy sources you go for water electrolysis. You generate hydrogen from the process, then you by actual physical transportation by trucks where the hydrogen liquefied and transported, you can handle the hydrogen, or you can go for converting that hydrogen into methane or ammonia, which are used as typical hydrogen carriers. and then at the point of source they are again converted back into hydrogen, or you use in the pipeline along with the blending with the methane, and then you separate out that hydrogen from the pipeline at the end, or you directly transport electricity at the point of utilization, and at that particular source you convert water into hydrogen by splitting up the water to electrolysis. And then there are various end usage to this, like you blend hydrogen with CNG to produce methane, which is a high energy methane in one form. This can be utilized in the conventional CNG vehicles. You can use that hydrogen for your powering your houses in industrial various applications, uh, or for running your data centers or other applications where the power is required. So this is a typical map related to hydrogen cost of generation and supplying all over the world. So from the analysis, it can be seen that India, Brazil, or Norwegian countries, that region can be a low cost green hydrogen supplier for the world. In India, because we have the infrastructure, we have some good resources, be it biomass or be it kind of solar based applications. So we can produce the hydrogen at around $1 by 2030, and that can be supplied to all over the world at cheaper rates. Typically, when we are talking about hydrogen production in India at somewhere around $3 to $4, in today's scenario, the similar cost of production of hydrogen for Europe as well as for American countries is somewhere around $6 to $8 for production, and that cost goes up for utilization up to $13 to $14 a kg of hydrogen, which is very high. Hydrogen is also kind of if it is utilized or generated with proper roadmap, can address our climate goals also, because of all the things that we spoke about. And if we talk about our green hydrogen mission, we are talking about 5 million metric tons of hydrogen production by 2030, with installed capacity of 100 gigawatts of electrolyzers, and to have 125 gigawatts of renewable energy capacity for green hydrogen generation. So if this happens, we can have bigger benefits. We can have around 1 lakh crore rupees of import saving, around 50 million metric tons of annual CO2 reduction from the atmosphere. Will have around more than 500,000 of jobs produced for entire hydrogen value chain in the country, and this can attract more than 8 lakh crore of investment in the country. For this, Government of India also launched a hydrogen mission, and which has outlay of around 19 or 20,000 crores of rupees. The main intention is to make the hydrogen infrastructure ready in the country in the next few years to meet our hydrogen mission targets and our emission reduction targets as well. Let's skip this part. It's all about policy related things. So as I was talking, main focus for green hydrogen generation is on utilizing solar or wind energy to generate hydrogen. But India is also blessed with a lot of biological availability, biomass availability. We are also an agrarian economy where we produce a lot of agricultural products, and along with that, of course, a lot of agricultural residue as well. What if that crop residue is utilized for generation of hydrogen? Because if you take case of Punjab or Haryana in particular, around 30 to 40 million metric tons of agricultural residue is getting produced over there, and is burnt in just couple of months, which causes tremendous amount of pollution generation and results in polluting the environment in the region, especially Delhi region. And that's when the people announce that odd even thing on the road to bring down the pollution levels. But actually, if you see, the reason is totally different. It's because of burning of paddy straw in the Punjab and Haryana region, and which is actually causing a main problem. So what if that kind of residue which is burnt otherwise, if we utilize for generation of fuel or hydrogen, what impact will it create? So, and where such kind of agricultural residue is not available, can we think of generation of biomass dedicatedly for energy generation or hydrogen generation, which can have a closed loop kind of economy for assured fuel supply, having a carbon neutral or negative production approach, and bring in, boosting up the agricultural economy of the country as well. So this is actually an ideal model where you can generate hydrogen in a decentralized manner, use your agricultural residue, have energy farming where the biomass is not readily available, and produce around 6 million tons of hydrogen by using this particular aspect. Entire potential is of 6 million tons, whereas we have kept our target of 5 million tons for 2030. So there are two processes that we were focusing upon for generation of hydrogen from biomass. One of this is the microbial process where you take biomass, microbial decompose that to produce hydrogen. The slurry or whatever left in the microbial reactor is sent again to the next reactor where you generate methane out of it. That methane can again be converted into hydrogen by steam methane reformation, and you get more hydrogen from biomass itself. So you get around 1.25 kg of hydrogen or around 1.5 kg of hydrogen also from 50 kg of dry biomass from this particular process. You can also go for biomass gasification where the biomass that is available is not easily degradable by using microbial process like wood chips or your coconut shells, apricot shells, which is hard biomass, cannot be degraded by using microbial things, can be converted into hydrogen by using gasification process. So you take that biomass, you gasify it to produce syngas out of it, and then that syngas is processed further to generate hydrogen or pure hydrogen. This all thing will bring in a lot of benefits, like being a biomass abundant available in the country, it will be a reliable source of energy. Based on appropriate technology suitable for that particular biomass, you can have decentralized generation of hydrogen over there, and the supply or production will be since it will be nearer to this point of utilization, the cost of handling of hydrogen will be also significantly low. As hydrogen is a lighter element, as I told you earlier, the compression, storage, and its transportation involves significant amount of cost. If strategically placed near the point of utilization, this cost can be brought down significantly. Again, as you are going to use your waste products for generation of hydrogen, it will reduce pollution as well as the waste which is burnt otherwise and cause other problems. So that is another benefit that we have. Because biomass is involved and we are aggregating economy, this will provide assured income for the farmers. So since the supply, the demand for the fuel or the energy will be consistent, it won't fluctuate the rates based on demand and supply, and will have a assured steady source of income for the farmers. And again, across the value chain, wherever the manpower is required, it will call for creation of jobs and also bring in significant value in that particular aspect as well. And the processes that I spoke about not only generate hydrogen, but there are certain byproducts also. Like from the microbial process, you get good quality of organic manure that is produced. CO2 also produced. If it is captured, CO2 also has significant applications in welding industry, in beverage industry, for cold storage in the form of dry ice. There are a lot many applications for CO2 as well. In the case of gasification also, CO2 is produced. And apart from that, you get biochar. Again, biochar has all various demand from industrial application as well as in the farming, where the biochar is thrown into fields to improve the fertility of the soil. The process carbon negative end to end if you consider, and this will bring in lot of carbon credits. If traded in the global market, this will provide good amount of revenue for the country. This can also be transferred. The benefit of carbon credits can be transferred to entire hydrogen value chain, making it further economically viable. So what people are talking right now about making hydrogen available at $1 can be made to certain extent by means of carbon credits also. it's less capital intensive compared to solar or wind energy based hydrogen generation. Because in case of solar and wind, you have to create that solar and wind farm first. Then you have to utilize that particular energy in electrolyzers, which is again a kind of capital intensive as of now. And then you have to utilize that hydrogen at some other different source. So transportation cost is also involved. So this makes the entire solar-based hydrogen little costlier. I personally believe that biomass-based hydrogen can be less capital intensive compared to solar or wind thing. And this can make India Atmanirbhar or Bharat Atmanirbhar because you are going to use your own biomass, you are going to consume the hydrogen internally for your own energy requirements, and thereby you are going to clean up your waste in the country as well as the CO2 levels also, because you are going to reduce CO2 levels as you are going to use the biomass for energy generation because the process is carbon negative. This is just a small, concluding slide that I have talking about sustainable development goals. The hydrogen-based economy can address all the 17 goals either directly or indirectly. So the green ones that I highlighted over here are getting addressed directly, and the purple ones are getting addressed indirectly. So, for example, you can get affordable source of energy. Then there will be decent work and economic growth. Industrial revolution will be there. Climate action will be as a part of this particular thing which will be directly addressed. Indirectly, if you see, you are addressing the poverty, you are addressing your educational aspects, zero hunger, clean water, sanitation. You are going to preserve your life below water, life on land, because you are going to use sustainable energy or sustainable technology, where you are not going to require precious earth elements also like platinum or ruthenium, which is required otherwise in case of electrolyzers. And overall, if you see in this particular context, this will address all the sustainable development goals, making the biomass-based hydrogen truly sustainable in its own way. So, to summarize, if you look at this particular hydrogen solution, it is addressing the social aspects, it is also addressing environment aspects, it is also addressing economic aspects, making it truly sustainable. So, thank you.
Thank you very much, Kaustubh, detailed presentation. It was highly scientific and technical. However, you were able to convert it into a simple, palatable kind of content to the participants. So now I request the working group members to respond to the presentation made by Kaustubh. Over to the members.
Prakash was advisor in MNRE, so he must be knowing the inner things about the green hydrogen. And I'm sure Sanjay Banerjee will be very happy. That is what I mean. All the sustainable development goals are covered by this type of technology. Others also can express themselves.
Pranam, thank you, Kaustubh, for a detailed presentation on hydrogen, and I really find a lot of value in this. Already it is too late, and we can go for keep on talking on this. But two fundamental points are there. Hydrogen, as you rightly said, hydrogen is not a source of energy; it is an energy carrier. And in nature, hydrogen is never available in the free form, because it is highly volatile and it reacts with one or another and create some kind of compounds. So the first point is why we should go for hydrogen. Why we should go for hydrogen, and what is the basic underlying objective for utilization of hydrogen for energy purposes. So since last 3 decades particularly, a lot of efforts are going on. I will not go into detail, but one thing is there. main focus for hydrogen today is that if there are certain sector where you can decarbonize the economy, particularly electricity or other sectors, but there are certain sectors where decarbonization is not that easy, and that is known as the hard to abate, where abatement cannot be, like particularly the industrial sector where like making ammonia, fertilizer, explosive making, or taking of cracking of the petroleum products, or steel making process. A lot of carbon emission is there. So these things thought that we should go for basic energy generation systems. Electricity in the form of energy carrier in the electricity is electron, and for other purposes it is the nucleus, that is the proton. Electron, hydrogen has one proton and one electron. This electron is for electricity purposes, and the proton is for energy generation purposes. You rightly said energy density is very high. All things are there. I give a typical example that when you are doing some economics, reality check of economics. Two examples I'll give. Solar energy has crossed the barrier of 2 rupees per unit generation cost, just generation cost. Forget about transport. If we generate electricity at 2 rupees per unit, this electricity is converted into hydrogen to store it, and that hydrogen is again converted into electricity. If we use that electricity to generate hydrogen, you require electrolyzer, and then from electrolyzer you get hydrogen and oxygen. That hydrogen again is utilized for electricity generation. Then you require a fuel cell. It is a reverse process of electrolyzer. Fuel cell and electrolyzer both are interchangeable. The cost of generation in the 2021, if 2 rupees per unit electricity generation is from solar energy, then this electricity again from converting into hydrogen, and from hydrogen to again electricity, stored hydrogen electricity, it was costing somewhere between 25 to 30 rupees. Implies that it is very costly. So these are the issues somewhere. This needs to be looked into, but in any case, it is a great presentation, and we can always build on this in the future. Thank you, Pranam.
Thank you, Mekanaji. Others, Professor.
Yeah, Kaustubhji, wonderful presentation, huge amount of learning for me. I'm still trying to digest it, and I also had the same questions like Mekanaji asked, why are we going for hydrogen? That is just a carrier and not kind of original source. And decarbonization, if that is the basic reason, then possibly it holds some promise, etc. I must admit that this is completely new subject for me, so let me try to digest it a little bit more. For me, what looks very promising is what you did at the end, where that bio sort of those bacteria, they are made to work on things that produce hydrogen. That is used. That to me sounds to be most promising. Like the compressed biogas route that we are talking sometime earlier. So then the question will come that between compressed biogas or biohydrogen, which one is more cost effective if both of them are equally sort of beneficial for decarbonization. This is my first take. I'm not sure if I'm saying the right thing, but this is my perspective. But thank you very much for a wonderful presentation. I'd like to have a copy of the presentation if possible.
Thank you, Professor.
Thank you, Banerjee, sir.
Yeah, maybe I'll request Kaustubh to share the presentation slide to the working group members in the WhatsApp group. It will be beneficial.
Sure, sure. I'll modify and share that. Definitely. So, Banerjee sir and Maithani sir, you both asked the same important question that I also had in my mind. Why to go for hydrogen when you can go for methane or CNG, CBG, compressed biogas? Because it's very easy to produce compared to hydrogen and can serve the same purpose. So I also have been debating for my entire career why I'm working on this. What's the benefit of hydrogen? The only benefit that I see, which will be important in say 5 to 10 years, I personally believe, is that you can get an opportunity to capture CO2, which is getting produced in the process. So, for example, if you generate biomethane or biogas and utilize for your transportation application, when you burn that methane for energy generation, there will be CO2 produced, which will be emitted in case of transportation through tailpipes of the vehicle. This CO2 is not easy to capture. Though we all agree that this is carbon neutral because the carbon or the CO2 that is captured from plants is getting released back again into atmosphere, then making it kind of carbon neutral process. Still, the CO2 in the air is getting released back into the atmosphere. However, if we go for hydrogen generation, we have an opportunity to capture the CO2 at the point of source itself and then sequester it or utilize where otherwise the grey CO2 is getting utilized. So, generation of hydrogen will give an opportunity to capture CO2 at the point of source itself and to displace the other CO2 generation applications or to sequester this particular CO2 into ground back again. So, for every cycle of generation of hydrogen and utilization of hydrogen, we can have an opportunity to reduce the CO2 from atmosphere, making it carbon negative. So that's the only benefit that I see.
I just want to interrupt you. Can you please explain why in CBG production CO2 capture is difficult, and in hydrogen production CO2 capture is easy? Why is this difference?
Yes. So in case of CBG biogas, the methane that is utilized for energy purpose. When you burn methane, that methane will produce CO2 and water. So methane, when reacts with oxygen, will give you CO2 and water. When this reaction happens in the engine of vehicle, the exhaust of that particular vehicle releases CO2 back into atmosphere. Now there are millions of vehicles that are running around the road. So even if all those vehicles are converted to CNG,
I get it.
Yeah. So it's more easier to capture the CO2 at point of generation of fuel itself, at the source itself, than at the tailpipe of the vehicle.
Yeah. So what you're saying is that in case of CBG, it's all dispersed and it's very difficult to capture. But in case of hydrogen, it's at the source, and then it is easy to capture. That's what you're saying, right?
Yes, easy and in concentrated form.
Kaustubh, this is Valliyappan. So thanks for the presentation. Actually, so far we have heard about hydrogen as an alternate fuel. So to get some more information about it was very helpful through your presentation. The only question that I have is, in case of artificial rain, I think some experiment was made some time back in Dubai and all. So is this the hydrogen also being used as a medium to generate artificial rain or anything? Any research is going on this?
No. In case of artificial rain, as far as I know, they utilize silver-based compounds which help in which act as a steading agents for capturing moisture from the atmosphere. So that aggregates all moisture from the atmosphere to form clouds artificially, and when all those clouds are saturated, then that water drips down in the form of rain. So that has not anything to do with hydrogen, because there is no electrochemical reaction that happens in the atmosphere. It's all physical phenomena, physics-based phenomena which is utilized for artificial rain.
Okay, thank you.
Kaustubh, you rightly said that very big ship came to Kerala 2 days back, and our minister, Mr. Sonawal, he visited, he received that ship, but I was not knowing that the ship was using this part of the fuel was hydrogen. And that fellow who was having the owner of the ship was the company second largest in the world. Incidentally, the Sonawalji, before going to Kerala, he came to Kanyakumari. That is how I came to know about it. Thanks for the
Okay.
information.
Yes. So I think Kerala is becoming a very big hub for hydrogen in the country because Kerala's IS officer K.R. Jyotilal, he is very active in the hydrogen domain. And the ship
welcome
that
back to this US Open office
to
plan.
shores,
Miller just lobbed a message way over Jones's head
prior to
using
that,
some
also there was
technical
one
jargon.
yacht with a crew of say around 4 to 5 people.
Welcome
only,
to the futuristic
which
oasis
was
of
running on
Dubai, where the
solar power as
impossible
well as hydrogen.
becomes possible.
That visited a couple of
In
years
this
ago.
mind-blowing
So this is, I
video,
think, second
we are
vessel that has visited Kerala's shore. And also we have our own indigenous KPITs and Cochin shipyards vessel that is already plying in the waters over there.
Yeah, no, more than Cochin, I was also not knowing earlier. Near Trivandrum, they are going to have a very, very, very big port.
Yes.
Millions of dollars government of India is investing.
Yes.
And our Kanyakumari area on Kolachal, there will be a sub-hub. Because our own people were against this, so the government of India, they have diverted and gone there. But it is going to be one of the largest in the world.
This is a private plane full of salt. We're gonna drop that salt in the air. Why? For the first time ever, I want to tell you the story of how this country creates rain. Here in the United Arab Emirates, the weather is very dry, which means in the winter, weather is really nice.
Then let us.
Puttalam, you would like to make any comment? I hope Puttalam is there. Yeah.
Sir, I'm here.
Nice, but it also means there is very little rain, and humans need rain. So the Emirates built this command center with one mission: make it rain. Here is the step-by-step process. They monitor all the skies in the country in real
Those are
time.
on large scale lines. So I hope someday those things would be available to rural people in smaller things. The government policy and many things have to happen. Good information, sir. Whatever I have got here, I have got some points about how the website can be taken forward also and discuss with you, and probably during the next call I can share with the team, or even the third call we can present, sir.
Yeah.
Mukherjee sir, to add to your point, the entire green hydrogen aspect that I put forth over here actually has main focus for rural area itself.
Yes, because
the biomass is coming from the villages where nearby the agricultural practice is going on significant levels, and which is near to highways. So the vehicles which are flying from city to city, they of course travel through this the way or roads going through the villages or near to the villages, and they can actually fill in their vehicles along this particular routes where the hydrogen stations will be displaced near to villages. So ultimately, though the aim or end benefit is for the cities, the intermediate or indirect benefits is for the villages, and which is more predominant because it is going to create employment and source of income to the farmers in those villages itself.
Thank you, sir. Thanks for all the information.